everyone. Welcome back. I hope everyone's having a great time so far today. It's my pleasure to introduce our next speaker, Darko Matovski. Darko Matovski, PhD, is the CEO and co-founder of CausaLens. The company is leading causal AI research, a way for machines to understand cause and effects, and serves some of the most sophisticated organizations. Darko has also worked for cutting-edge hedge funds and research institutions. For example, the National Physical Laboratory in London, where Alan Turing worked, and Man Group in London. Darko has a PhD in machine learning and an MBA. Please join me in welcoming Darko to the stage.
Hi, everybody. Thank you so much for taking the time today. My name is Darko, and I'm the CEO of CausaLens. At CausaLens, we build AI that humans can trust. So here is what the problem with existing approaches. Existing machine learning systems use correlations to learn patterns from past data. And then they hope that the world is going to remain very similar to what they've learned from past data. And they tend to make predictions based on that. But that's actually a problem because the world in the real world changes all the time, and what's recorded in past data, those patterns, they tend to change over time. So it's not actually a surprise that correlation-based machine learning or current state of the art cannot be trusted because it simply cannot reason. It looks at the world through a set of random numbers, more or less. Here's a bit of evidence to show that current machine learning systems kind of remain basically in the lab. 87% of machine learning projects never make it beyond the experimental phase. 80% remain at proof of concept stage. So depending on which number which study you look at, 80 to 90% of AI projects or ML projects never see the light of day, and that's quite worrying. The key reason for this is because human decision makers simply do not trust correlation-based machine learning. And here's a fun example of what would happen in the real world when you use correlation-based machine learning. It simply cannot reason about the world. So because it looks at the world through random numbers, if you just gave it some data about shark attacks and some ice cream sales, and you said to a correlation ML system, can you learn how to predict ice cream sales? A correlation-based system will learn that, oh yes, I just look at shark attacks and I predict ice cream sales. So more shark attacks, more ice cream sales, that's my model. But what correlation-based machine learning cannot do, it doesn't understand that there is a variable or a confounder here, sunny weather or summer, that is actually the causal driver that affects both shark attacks, because people go to the beach when there's nice weather and they get attacked by sharks, but they also eat ice cream when the weather is nice. And so correlation-based ML is completely blind to this idea of confounders, things that are maybe not present in the data. So this is the same example, just illustrated a bit differently. Eating more ice cream will cause more shark attacks. I guess the point here is that correlation ML also has no direction of causality. So ice cream is correlated to shark attacks, but which way around is it? Should we be using shark attacks to predict ice cream sales, or use ice cream sales to predict number of shark attacks? Correlations simply have no direction. They're just an absolute number between -1 and 1, and therefore have no direction. So we have a bit of a problem when we use this in the real world. Now, let's get away from fun examples into the real world. We've seen severe consequences of correlation-based machine learning. We've seen people losing a lot of money in financial markets. We've seen people being wrongly accused when it's using the judicial ML system. We've seen a lot of bias when correlation-based ML is used in the judicial process. We've seen a lot of people being not treated in the health care system because the AI may not have had the right data. We've seen significant bias because maybe the data is biased to a particular ethnic group or worse. So these are real failures of correlation-based ML, and even the most well-funded players are struggling to build trustworthy AI. Now, luckily, we have brought a completely new category of machine learning to market, Causal AI, that can actually tell the difference between cause and effect relationship and spurious correlations. The world's thought leaders, the academic community, the business community, everybody now agrees that this is the direction of travel for the entire technology. Let me just quote Joshua Bengio here, who is a Turing Award winner. He said, causality is very important for the next steps of progress of machine learning. So Causal AI is very human-centric. And what we see with our clients is that actually they fully trust the AI. They fully trust it, even in situations that haven't occurred before. So Causal AI, for the first time, lets you decouple models from the data. So there's three nice things about Causal AI. The first thing is truly explainable. And I mean really truly explainable, as opposed to, fitting a black box and then building another model like Lyman Sharp to try to explain the black box. It's completely fair because it reasons about the world like humans through cause and effect relationship as opposed to spurious correlations. And it's very reliable, and it can perform well in situations that may have not been observed in the past. And I'll take you through each one of these now in great detail. So normally you have a trade-off between explainability and accuracy. So a linear model may be very explainable, but it's not very powerful. A deep neural network may be very good at fitting data, but it may be very hard to explain. And I'm fully aware of the exposed explainability techniques like Lyman Sharp and so on. But we're not talking about that here. We're not talking about another model explaining a black box. We're talking about completely intrinsically explainable models. Now, causal models are as well performing as neural networks, sometimes better, and they are as explainable as linear models, i.e. they're intrinsically explainable. So they're explained ex ante, before the fact. Before you build it, it's explainable. And now I don't have time to explain how that works, but if you go to our website, CausaLens.com, you can read about this. We have a really nice white paper on it. So please feel free to go there and understand, if you want to understand this in greater detail. But let me illustrate it through an example. So correlation-based machine learning system will do the following kind of thing in a case of, in a case of churn. So it would say, the machine learning will say something like, this customer segment has 87.4% chance of churning. And then a business person will say, well, okay, that is a problem. What can I do? And a black box would basically just tell you, I have no idea. I just make predictions. Is someone going to churn or not? And then, a business user would say, but could you tell me at least why you think they'll churn? A black box machine learning system would say, well, no, I have so many features that it means nothing almost to human. But then the correlation-based explainable AI method like Sharp would say, oh, look, let me come in and help. I can see a lot of customers whose names begin with A are churning. So, explaining it through a Sharp, you will get kind of some silly answers like this that make no sense to a human. But let's run through this exact same example through Causal AI model. So Causal AI will say, look, your customers have 87.4% chance of churning. Business person will say, well, yeah, that is a problem. What can I do? Causal AI system actually can give you a decision and can help you make the right intervention. In this case, increase the customer discount by 20%. Now, a business person will be like, oh, that's a bit much. Could I remain, can I stay at 10%? But could I do something else? And the Causal AI will actually tell you that there's actually more than one intervention you could apply. And the optimal intervention in this case is increase the discount by 8% while increasing sales calls by 2 a month. So what you can see here is that a Causal AI model is one superiorly explainable, and the second thing is it takes you away from blind predictions to actual decisions, and this is kind of a big deal, we think. Now, I don't have the time to take you through the details of the fairness, but one thing I would say is that what we've observed with clients, but also with some of the kind of the big players in AI like Apple and Facebook and so on, is that it's very easy to pick a bias in past data. Like, it's too easy. Because the machine is looking at the data through random numbers and is like, oh, let me find some correlations. Oh, look, I found correlations. I'm going to build a model. In this case, the gender actually may be correlated to whether you should give a loan to someone or not. And that's what a system, current ML system would use. It will just say, I'll just use the gender. It's really correlated, great. But actually, you don't want to use gender in your decision making for loans. You want to use something like income, which is correlated to gender, but a causal system will tell you, yes, gender is correlated to both whether I should give someone a loan, and it's correlated to income, but I'm going to just use the income as a causal driver, and I want to eliminate the gender. I don't want to use that in my decision. And so when we did this in the real world, we observed that we made 6,000 plus better, fairer decisions versus what the customer had in production. Now, finally, causal AI is truly reliable. I just want to compare deep learning network with a causal diagram, just to give you a sense of how what is the difference. Imagine each one, and by the way, this is just 3 hidden layers. This could be a lot bigger in a deep neural network. And each one of these nodes have coefficients that connect them and activation functions, and it's truly complex. Whereas a causal model is very simple. You can see it here. You can see the cause and effect relationships. It's interpretable from by anyone, even by compliance department. Now, I just want to show you one example here of a AI system, going wrong, and it was in the case of sauce and condiment retailers in India. The correlation ML system was working just fine when the world was normal, but soon as the pandemic hit, people started making very large bulk orders and that the system had never seen before. And so when this happened, essentially the covariance matrix of the model completely broke, and the model was doing some really wild predictions. It was basically saying we should stock more of the stuff that doesn't sell, because the covariance matrix got inverted in the process. Once the correlation ML model saw a data point that was never observed in past data, completely wild from kind of the distributions it was trained on, it started making completely the opposite decisions. A causal AI model would never do that, actually, because the causal diagram will constrain this behavior in a way that this kind of things would never happen. And so in addition to the 3 kind of key pillars of causal AI, which are, causal models are truly explainable, they're truly fair, and they're reliable no matter what happens. To bring this into the hands of business, for business to trust it, you also have to have a very intuitive way of bringing this technology in the hands of the business. And that's what we feel is the missing piece today, and that's what our product does. It's a no-code platform that brings this wonderful, sophisticated technology, and it makes it super simple for anyone to be able to use. And this is just a bunch of examples of doing this in various industries. This one, for example, is about optimally allocating billions of dollars in real estate. But I'm not going to bore you with that. If you want to learn more about causal AI and why it is the future of the technology as a whole, is the future of AI, here's a bit of a suggested reading. A good starter is the Book of Why by Judea Pro. But if you would like to learn some more, just come on our website, CausaLens.com, and we have plenty of cool reading materials there. Thank you so much for listening today. This was very brief, I know, but just ping us and we'll be super happy to take you through use cases and a deeper dive into our into causal AI and the science behind it. Thank you so much.
Thank you, Darko. That was awesome. A big virtual round of applause. Hear that virtual audience roar. We'll see you later, Darko. What a great talk. I hope you all enjoyed it. Please make your way to your next session. Also, don't forget to check out the networking, accept your connection request, and explore the AI exhibits. Have a great time.